Hi Precalculus, this is question number 2 from the chapter 3 review. It says find the roots of the polynomial p of x equals 4x to the fourth minus 4x cubed minus 7x squared plus 12x minus 15, given that 1 minus 2I over 2 is a known root. Alright, so we know here that we have 1 minus 2I over 2 is a root. Using the complex conjugate theorem for a polynomial with real coefficients, we know that 1 plus 2I over 2 has to be a root as well, and we could write that as 1/2 minus I and 1/2 plus I because they come in conjugate pairs. Okay, so the neat thing is the shortcut would be to say, okay, if I know that 1/2 plus or minus I is a root, one quick way to get to what the factor that generates, the quadratic factor that generates these two roots may be, is to subtract this real portion over, leave the plus or minus imaginary portion on one side, and then square both sides. Okay, so on this side we get x squared minus 1/2 squared times 2. Oh, sorry, 1/2 7. So just x plus 1/4. Okay, if we FOIL it out correctly, I think. And we get I squared here, because the squaring takes care of the plus or minus, which leaves us with x squared minus x plus 1/4 plus 1, because this is actually equal to -1, right? And I'm going to add it over. Okay, so I get x squared minus x plus 5/4. And if we multiply through by 4, we could write it, depending on whether we're going to factor out that 4x squared minus 4x plus 5 equals 0. So that would be one way to do it. The sort of longer method would be to actually write out both our factors, right? Because given we know a root, that means x minus 1/2 minus I and x minus 1/2 plus I are both roots. And so we could FOIL things out here, and hopefully it should work out the same thing. It's a good check for this time. Remember, on a test situation, I would just do the method that sort of you're more comfortable with. I get x over 2 plus ix. Oh, sorry, minus ix. Might be doing this a little quickly. So let's see, x times -1/2 x minus ix plus, oh, again minus, x over 2 plus ix, and then plus a difference of perfect squares here, 1/2 minus I, 1/2 plus I. Okay, and so that leaves you with x squared minus half x minus half x gives you 1 full x. The negative ix and the positive ix cancel. And then I have 1/4 plus 1/2 I minus 1/2 I, so 1/2 I, minus I squared. And that's looking like it's going to give us these two canceled plus another 1, which gives us the same factor of x squared minus x plus 5/4. Okay, so now this next portion is, can I take this factor and divide it through? So this is a good chance for us to practice polynomial division as well. So I'm going to take this, copy it, and let's start on this fresh page just to give us a good refresher of what it's going to look like. But if I try to line things up here, because I don't have a linear divisor, I'm going to actually have to do out 4x squared minus 4x plus 5. Okay, so we ask ourselves, it's the division algorithm, right? What do I multiply 4x squared by to get 4x cubed? I multiply it by x squared. Now take this and multiply it by each of those three parts, right? And this is the algorithm we repeat. So we get 4x to the fourth minus 4x cubed plus 5x squared, right? And the way I like to do it is I change those signs. So there's a plus here, I change it to minus. So this cancels, which is awesome. And I end up getting negative 12x squared plus 12x minus 15. Now we do know it's a divisor, which means the remainder, when we divide by that divisor, is should be 0. So here, what do I multiply 4x squared by to get negative 12x squared? I multiply it by negative 3. And again, do the same process and you're multiplying. I don't have to do it each time, but we're multiplying it by all three parts. So I get negative 12x squared plus 12x minus 15. And okay, hopefully that's what we were expecting. I'll just stay consistent with my sign change here because I'm subtracting. Right, so this cancels, this cancels, this cancels. I get a remainder of 0, which works. I might move this up here just to have saved some space. Oops. I didn't realize it would be so short. Actually, it's all good. We can leave it down here. We're not wasting much paper. Okay, so our remainder was indeed 0. So now what we've done is we've taken our polynomial p of x, which is equal to 4x to the 4th minus 4x cubed minus 7x squared plus 12x minus 15, and we've expressed it as a product of 4x squared minus 4x plus 5 and x squared minus 3. Now that we have it in factored form, we can go back to the original question, which is asking us to find the remaining roots. Now, it's a quartic polynomial, which means it has 4 roots. We had found 2 of them. The other 2 are going to come from this. So when I set x squared minus 3 equal to 0, it's going to give me x equals plus or minus the square root of 3. So my set of roots are 1/2 plus or minus I and plus or minus square root of 3. Okay, so complex roots come in conjugate pairs. So do irrational roots when it's a polynomial with real coefficients. Okay, hope that was helpful.